So the first part of the question A, they give you a situation. They say when after 15 minutes, the temperature is 20 degrees Celsius. So what we do is we put into the equation. Yeah. So I replace the T with 20. And I replace the time with 15. Okay. Then you start calculate for T. Then you start calculate for K. Correct? Yeah. So the rest of the calculation, I will leave it to you. So 20 minus 9 will be minus 5 will be 15. So I will have my e to the power of negative KT will be equal to 15 divided by 95. So I simplify, that is 3 over, is it 3 over something? $19. Yeah. 20 minus 5 is 15 what? 15 divided by 95. So it's 19. Correct? Okay. For me, if I want to solve this correct, I always write this as 1 over e to the power KT. That is equal to 3 over 19. So from here, I got my e to the power of KT is 19 over 3. I flip it the other way around. So therefore, my K, the T, I'm supposed to put 15, am I right? Sorry. I'm supposed to put this as negative 15K. So here will be 15K. So here will be 15K. So my 15K will be equal to ln 19 over 3. Am I right? So K will be equal to 1 over 15 ln 19 over 3. So you can use your graphic calculator or scientific calculator and count what is the approximate value of this. Can someone give me the approximate value for this? 0.123, right? Okay, got it? So that is how you use the information. Okay, so that now they say, what was the temperature of the liquid when it was first? So the word first means this. Okay, so I will now put the TS equal to, so now T equal to, temperature equal to 5 plus 95 e to the power of negative K times 0. So this is 5 plus 95 e to the power of 0 is 1. So the initial temperature is 100 degrees Celsius. So you see, sometime in the question, especially when you talk about problem solving, they don't say initial temperature. You see or not? They will say first put in. That means T equal to 0. You have to know that. So you have to know that what are the words that represent T equal to 0. Do you get me? Okay, now to do part C, what I will do is, they say show that. So now I have to get my dt over dt expression. So now I'm going to write my T. I'm not going to replace my K with this value because it will make my calculation and my differentiation very troublesome. I will write K as K first. Okay, when I want to count the value, then only I substitute. Okay, so you have to know when to replace and when not to replace. So never ever replace K with that funny value first. So I will differentiate this according to what? Using exponential term. So D temperature over D time. So I don't say dt over dt, okay? Because both are pronounced as T, equal to rate of change of phi is 0. Okay, exponential term, you copy down the whole thing. Then you time by the derivative of the constant. Am I right? Okay, so this one become negative K times 95 e to the power negative KT. So, have I shown what the question want me to show? No. Okay, if not, then I have to think of a way. So I have to see what I can do. This thing, is it the same as this? So from here, can I say my 95 e to the power negative KT is equal to T minus 5? Can I say so? So if that is the case, then I can replace that so negative K, is it a constant? So it will be equal to a constant times T minus 5. The constant is the negative K. So I shown. Are you clear? So that is how you show. So in this case, the C is equal to negative K. Are you clear? So done with that. So for part D, at what rate is the temperature changing? So this one should be very easy, correct? You have your KAD. So what you can do is for part D, I will key into my graphic calculator y1 equal to 5 plus 95 e to the power negative 0.123 x. Then I use my y2 to solve all the rest of my problem. So you just need to call out your y2 to do part 1, part 2, part 3. Are you clear? So for this question, the key is this one and this one, the new thing. Are you okay? So part D, I will not go through the answer with you. You should be able to do it using your graphic calculator and get the answer. Your answer may be slightly different from the textbook because the K we use the approximate value, unless you key in the exact value here. Are you clear? Don't do texting when you are in the class. Try not to get distracted. Okay. Got it? Done? Okay, good. Okay, huh? Before I go to question 12, I would like to talk about something else before I go to question 12, huh? Okay. Can I? Okay. Still remember on page 83, we have this very special function for question 10. Okay, I just write down the function. Okay. Okay, if you have a product of a linear term and an exponential term, this special function, we call it the search function. They cut it out from your syllabus, but I'm going to tell you. Okay, and this search function, correct? It have a special feature. Okay, I put here T, sorry. It have a special feature. Okay, you can go back and try to put in different number for A and B. It have a special feature like that. Sorry. And we see in this question 10, correct? It got one stationary point and one inflection point. Okay? And the x coordinate of the stationary point, correct, is always 1 over b. And the coordinate x for the inflection point, correct, is always 2 over b. So if you change the value of b here, will change. So this is a formula. You can write this one down in your one-page handwritten notes. This particular search function have a special feature. It got one stationary point, that is local maximum, is also global maximum, and you have one inflection point. That is the point whereby it is decreasing at the fastest rate. So if the question come out like that, then they give you, for example, I give you example. I give you a function, okay, gx equal to, okay, 3x e to the power of negative 2x. Okay, for example, I said, when, okay, don't want to put 2, I put 3x. Okay, I will say, when is gx decreasing at the fastest rate? Okay, if this is a question, I give you only 1 mark. You don't even have to use your GC if you have this formula. So I will straight away write down x when x equal to 2 over 3. That's it, done. Unless they say by calculus, then I have no choice. I have to put g double prime x equal to 0. Are you clear? So the advantage of writing this one down in your notes is whenever the question didn't say algebraically, you straight away can apply. You can go and test it out. Especially those who do spec max, you can prove by induction. You can put in different value, then you use your graphic calculator, you see the pattern. So I can come out this question as a conjecture as well. Still remember, I told you the conjecture question? Conjecture question means proof by induction. Hello? So this is a search function. I want to say this first because the question 12 that I'm going to discuss with you is another another function. We call it logistic function, whereby you have a special characteristic. Got it? Okay. Can you please turn to page 87? Okay, any application question on calculus, always remember, they give us a function, we can key in the function into the calculator, we go ahead and key in. Like just now, question 7, I didn't ask you to key in because I don't know what is the value of k. See or not? Okay, this one I know, so I just key into the calculator, and when you key in, you will have to be very careful because that will determine the rest of our question. So never rush when you key in the function. Are you clear? Because you are going to save a lot of time after that. So don't worry if you take a longer time to key in. Do you get me? Are you clear? So key in slowly, look carefully, check again before you use it. Are you clear? So this is something that you have to practice. Okay, this is called habit. So don't say, wait until exam only I do it. No, every time when you know the function for application, you just key in the function, double check. Okay, so key in already. So you use your graphic calculator, then you start to do part A. Initial means t equal to 0. You just key in, you call out your y10. Okay, percentage increase, always the final minus the initial divide by initial times 100%. So that is how you calculate percentage increase or percentage decrease. Okay, if percentage decrease, you will get a negative value. So that is called percentage decrease. Yeah. After 1 month means t equal to 1. Initial t equal to 0, final t is equal to 1. So I write down that, I get the answer. So you can check the answer from the book. Yeah. Okay, I'm going to do part C. So for part C, the word, is there a limit? The moment you see the limit, straight away know already. Yes, as t approaches infinity. When you talk about velocity, displacement, kinematic rate of change, all this correct, the time is always positive. So it will never go to the other direction. Yeah. So as t approaches infinity. So now, so what we need to do is, we always have to go back to the function. So this is our first issue. Am I right? Okay. So if e tends toward infinity, so what will happen to my e to the power of negative 1.73t? Will approach
Infinite. 0.
zero. Correct? Because you should know that every one of us, we should have in mind e to the power of a negative number, we always write down 1 over e to the power of a positive. Am I right? So 1 divided by very big, it's become very small. So approaches 0. So then the next one, we want to talk about this whole thing. So we tackle part by part. So what will happen to 1 plus 0.5 e to the power of negative 1.73t? It will approach
1.
1. Therefore, my BT, which is 3000 divided by 1 plus 0.5 e to the power negative 1.73t, will approach 3000. From below or from above? 1 is the smallest number for the bottom, correct? So the rest of the number will be more than 1. So that means 3000 divided by a number that is more than 1, it will be less than 3000. So it will be from below. All right. So is there a limit to the population size? The answer is a yes. If so, what is it? So if so, what is it? So how should we answer? We will just say the limit is 3,000, or we will say that the population will not grow beyond 3,000. Correct? We should say that the population of bees will not grow beyond 3,000. Yes? Are you okay? So we don't just say the limit is 3,000. We will want to give people the sense of whether it's the upper limit or the lower limit. Got it? Okay, done with that part. Okay, now let's go to part D. Okay, find B prime T. That means you have no choice to use calculus. So this is called a logistic function. So 3,000. So I bring the whole thing at the bottom up. So I'm using chain rule to find the derivative for this. So B prime T is equal to 3,000, multiply by the power, copy down the whole thing, young man, you finish your work already? You differentiate already just now? Okay, good. Power, take away 1. So what should I do next? Okay, young man. Yeah, since you have done it. Yes, yes, with the white jacket. Yes. You didn't do D. You didn't know how to do D. Okay. How many steps we have to do? Okay. So what you can do is you can use your calculator, multiply all this up. Okay, can someone take your graphic calculator and multiply and tell me what is the answer? Yes? 2595. No negative, correct? Because you got 2 negative there. Okay, 2595 e to the power of negative 1.73t divided by 1 plus 0.5 e to the power negative 1.73t squared. So this is your B prime T, and use it to explain why population is increasing over time. So when you want to explain over time, so you have to say T greater than 0. So what happened to e to the power negative 1.73t? Definitely always positive, am I right? And the one at the bottom squared. A square number, can it be negative? Always greater than 0. Therefore, B prime T is always greater than or equal to 0. Done. So this shows that it is always increased over time. Yeah. So next, find the rate at which the population is increasing after 6 months. Okay, that one, no problem. Am I right? You can use your graphic calculator. I will leave that part to you. You call out your Y2. Yeah, you call out your Y2, then you can get the answer. So for your part E, B prime 6. So using your graphic calculator, you call out your Y2 and you key in the 6, you get the answer. That's it. No need substitution at all. Okay. Now I want to quickly go to F. Can I move to F? Okay. So for part F, I believe, how is the graph look like? May I know? Like that. Or is there some sort like this? No, it go all the way up. Okay. So this is your BT and this is your T. So for this part, what we need you to do is when you sketch the graph, you have to draw the horizontal asymptote. That is y equal to 3,000. That's it. Can or not? Okay, so please go back and go through all this question. Okay, in exercise 3F. So tomorrow we will talk about 3G optimization. Then I will optimization. The difficult part is I will show it to you tomorrow. Okay, now this is called a logistic function. For this function, it doesn't pass through the inflection point. So I'm going to show you a logistic function. Okay, so a logistic function, it will be of this form. Fx equal to C over 1. Here is definitely a 1 plus A e to the power negative BT. Okay, so any logistic function, okay, the shape will be, we call it the S shape. Okay, and it definitely got one inflection point. The reason why this one, we don't have the inflection point because the inflection point is negative part. So when you involve time, it doesn't matter the inflection point. Are you clear? Okay. So the inflection point is at the negative part. Okay, so I draw this one. Okay, so the limiting value, this is always the limiting value, highest. And the inflection point, the value will be half of the limiting value. That is the characteristic. So if from here, Fx is equal to half, correct? So I try to find the T, I can't remember. So I sub into the formula and get the T. So C and C cut. Uh-oh, I really cut it. So that means top both got C, correct? So the bottom will be 1 plus A e to the power negative BT will be equal to 2. So A e to the power negative BT will be equal to 1. So e to the power negative BT will be equal to 1 over A. So 1 over e to the power BT equal to 1 over A, correct? So e to the power BT is equal to A. So the time here, the formula will go like that. Ln A over B. So this will be the time whereby it increasing at the fastest rate. So if you write this one down in your notes, whenever I give you a logistic function, you also can apply it straight away. Yeah. for this case, okay, can I go back? So there are two very special functions. One is a search function, one is a logistic function, whereby we have to record it down in our notes so that we can save a lot of time when the question asks for certain thing. Okay, now for our case here, F, you look at here, the increase at the fastest rate at the beginning because the inflection point is here. T cannot be less than 0. So that means if this question they ask, when is it increasing at the fastest rate? You will say at the beginning of the, when you study the population of the bee. That is when at T go to 0. Isn't it? The slope at this point is the steepest. Are you clear? Yes? I know. Don't worry about that. I know my time. Okay? So Ken? Okay, so any further question you can ask me tomorrow. Okay? The second lesson, I will talk about optimization. Yep. Okay, thank you, class.